Hello everyone, this is Dr. Lennon, and today we're going to go over the final exam review, which is just going to be 10 questions, and it's going to be comprehensive, so it's going to be over various topics we've looked at throughout the semester. So on this first one, we want to find the equation of the line that passes through 1, 5 and 3, -1. So recall the equation of a line looks like something y equals mx plus b, and the first thing we want to do here is find the slope. So we can find the slope using the slope formula, which is y2 minus y1 divided by x2 minus x1. So I'm going to have -1 minus 5 divided by 3 minus 1. So that comes out to -6 divided by 2, and that is -3. So now we know that our line actually has to look like y equals minus 3x plus the y-intercept. So what we want to do is we just want to plug in either of those 2 points and solve for b, and then we'll have found the remaining parameter. So let's plug in 1, 5. 5 replaces y, and 1 will replace x, and then we can just solve for b by adding 3 to both sides. So we see that b is actually equal to 8. So the equation of our line is y equals minus 3x plus 8. And that is the answer for number 1. Okay, so for number 2 here, we want to solve the quadratic equation by factoring. We're going to use the grouping method. So if you recall, the way we start that is we multiply the first coefficient 5 by the last coefficient -3, and we end up with -15. Then we want two numbers that multiply to -15, but when you add them, you get the middle x coefficient, -14. So the numbers that do the job are -15 and +1. So basically that means that we could rewrite -14x as -15x plus x. And that's what we're going to do. So we're going to have 5x squared minus 15x plus x minus 3 equals 0. And we want to pair these into two groups. So the 5x squared minus 15x and then the x minus 3. And we want to take out the greatest common factor from each pair. So from the 5x squared minus 15x, we can pull out a 5x. And then what would we be left with on the inside? We'd be left with, well, just x, because 5x times x makes 5x squared. And then minus 3 because 5x times -3 makes 15x. Now, x minus 3, there's no common factors. There's no shared variable, and 1 and 3 have a greatest common divisor of 1. So that's all we can pull out there is 1. So we're going to write this as plus 1 times x minus 3. And then the x minus 3 in parentheses becomes a GCF of each of these two pairs that we've looked at. So we can rewrite our polynomial as 5x plus 1 times x minus 3. And both of those things are being multiplied with each other. So by the zero product principle, that means that one of those two parenthetical quantities must be 0. So we can say, well, either 5x plus 1 equals 0, or x minus 3 equals 0. And we can solve each of these remaining linear equations to find the two answers. So we have 5x equals -1, divide by 5. So x equals -1/5 is one of the two solutions, and the other one is just 3. Adding 3 to both sides, we get x equals 3. So our two solutions here are x equals -1/5 or x equals 3. And that's it. So remember that you want to do this problem by grouping. If you're more comfortable with the quadratic formula, you can use that to check your answer, but if they ask for factoring, then you're going to have to show the factorization before you can go ahead and write down the final answer. So for number 3 here, we have a system of two linear equations that we want to solve by the elimination method. So what that means is we want to multiply either one or both of the equations by some number so that one of the variables has the same coefficient in front with opposite signs. And then when you add them together, you'll remove one of the two variables. So the easy way to do that in this case is just multiply the top equation by 2 and keep the bottom equation the same. and then you'll have a 6x and a minus 6x, so those will cancel when you add. So I'm going to multiply this top equation by 2, and that means multiply each term by 2. So the bottom equation is staying the same, so I can just write that down. Minus 6x plus 5y equals 50. And then the top one we're multiplying by 2, so we'll have positive 6x, minus 4y, and minus 46. So then we can add, and we'll end up with just y equals 4. So we've already found y. Remember, the solution to a system should be an ordered pair, so we're not done yet. We need to find out the x-coordinate as well, so we can plug this y equals 4 into either of our original equations. So I'm going to plug it in to the 3x minus 2y, so I'm going to replace the y with a 4, equals minus 23. So basically, if you want to know what's going on here, I'm plugging in to, let's say, the top equation, and then we're solving for x. So we have 3x minus 8 equals minus 23. We want to add 8 to both sides, so we're going to have 3x equals minus 15. And when we divide by 3, we'll have x equals minus 5. So the solution to our system is the ordered pair negative 5, 4. Remember, even though we found y first, the x-coordinate comes first when you're writing down the ordered pair solution. Okay, so for number 4, we have a word problem. A man has 14 coins, all of which are dimes and quarters. If the value is 260, how many of each does he have? So this is going to turn into a systems of equations problem. On the one hand, if we let the dimes plus the quarters, where D is the number of dimes he has, and Q is the number of quarters he has, that should add to 14. And then the second equation should be a value equation. So the dollar value of dimes, which would be 0.1 times D, plus the dollar value of quarters, which would be 0.25 times Q, that should equal the total monetary amount he has, which is 260. So as you can see, we have a system of equations. So the way I'm going to solve this is I'm going to keep the top equation the same, and I'm going to multiply the bottom equation by negative 10. That way we'll have negative D on the bottom. So we have D plus Q equals 14, and then on the bottom we'll have negative D minus 2.5 Q equals minus 26. So now when we add, we eliminate the D. So we have Q minus 2.5 Q, which is minus 1.5 Q. And then 14 minus 26 is negative 12. So then we just need to divide by minus 1.5. And we have our answer. So again, that's just going to be the number of quarters. So we're going to have to plug our result back in and find the amount of dimes as well. So we see that there are 8 quarters. So note, that's pretty easy. We know that 8 quarters amounts to $2. So we know dimes are basically going to be 6, or we could plug it back into D plus Q equals 14, which is D plus 8 equals 14. So we can subtract 8, and we see that there should be 6 dimes. So the man has 8 quarters and 6 dimes. And that's it for this word problem. Okay, for number 5 here, we're given a quadratic function, f of x equals minus 1/2 x squared minus 2x plus 6. So we want to find the vertex, all the intercepts, and sketch a graph. Again, you should kind of have a vague idea of what the graph should look like, right? You know the shape of a parabola, and by looking at that leading coefficient minus 1/2, since it's negative, it should be opening downward. So let's go ahead and go through each of these parts. So remember, the vertex formula is the x-coordinate occurs at negative b over 2a b is negative 2 here, and a is negative 1/2. So the first thing is to find the vertex. So the x coordinate there, we are using the vertex formula. So x should be negative b, which is the opposite of negative 2, divided by 2 times negative 1/2. So that is negative b over 2a, which is 2 over minus 1, which comes out to negative 2. So that's our x coordinate. To find the y coordinate, we just plug that x value into the function. So we're looking for f of negative 2, which is negative 1/2 times negative 2 squared minus 2 times negative 2 plus 6. As you can see, sometimes there can be quite a lot of negatives, so you really want to keep track of everything with parentheses and double check your work when you have this many negatives. So we have negative 1/2 times 4 plus 4 plus 6. So this is going to be negative 2 plus 10, so that comes out to 8. So the vertex is negative 2, 8. Okay, so now we want to find the intercepts. So the easier of the two intercepts to find is going to be the y-intercept. The y-intercept we know occurs at just f of 0. So f of 0 here is just negative 1/2 times 0 squared minus 2 times 0 plus 6. So this just comes out to 6. So the y-intercept is 0, 6. The x-intercept is a bit trickier. We need to set f of x, and then there could be multiple, there could be 2. So the x-intercepts could be 1, could be 0, could be 2. All are possible. We want to set f of x equal to 0 and solve. So we have negative 1/2 x squared minus 2x plus 6. So this is a quadratic. Let's go ahead and multiply both sides by negative 2 just to make the numbers a bit easier to work with. So we would end up with x squared plus 4x minus 12. That's multiplying all terms by negative 2. And then that should factor into x plus 6 times x minus 2. So we have two x-intercepts. The numbers that would make each factor 0. So we have negative 6, 0, and 2, 0. So those are the x-intercepts. So now we found all the intercepts and the vertex, and graphing should be pretty easy. So again, remember this is opening downward. So at negative 2, that's our vertex. We should be at 8. Again, drawing by hand is never going to look as nice in terms of scale, but I'll do my best. So we've got negative 6 as one of our intercepts, and 2 is the other x-intercept, and then the y-intercept was going through 6. So basically, if you would go, this is, 2 steps left, so 2 steps right. That should go through 6 as well. But anyway, this is the rough sketch of the parabola f of x that we were looking at. Again, it's not the best drawn by hand. It would look better on a computer, but that's not too bad. So that's it for graphing a quadratic. Just remember the vertex formula, and then the other intercepts can be found by just plugging something into a function and then possibly using either factoring or the quadratic formula. Okay, so for number 6 here, we have a synthetic division problem. And it gives you the way that you want to write your answer. So we'll talk about that at the end. So p of x is this polynomial minus x cubed minus 2x plus 5. So notice there's an x squared term missing, so we're going to need a 0 placeholder for that. And the divisor is x plus 1. So the root of d of x is going to be negative 1. So that's what we write in the corner. So remember the setup here is we take the divisor, negative 1, put it in this corner, and then on top we're going to write all the coefficients of p of x, which are negative 1, The 0, because there's no x squared, a -2, and then a +5, and then we write a line below. So we want to bring down that -1 to start. That just comes straight down. So we get -1. And then what we do is we multiply the -1 here with the -1 in the corner. So -1 times -1 is +1. And we write that above the line. So everything below the line we're going to be multiplying by -1. Now to get the next term we add. 0 plus 1 is 1. Multiply 1 by -1. Bring that above the line. Add -2 plus -1, which is -3. Take that -3, multiply it by the -1. And we get +3, and then add, and we get 8. So now we're done since we've finished with that last column. So what does this mean? Well, this means essentially that this is our result, our quotient. So these parts are representing q of x, and this is representing our remainder. So the way they want us to write our answer is they said they want us to write, so let's also remember q of x really here is going to be -x squared plus x minus 3, right? We go remainder, constant term x squared. They just keep increasing by degree. So when they want us to write p of x is equal to d of x times q of x plus r of x, we just plug in all the results. So it's a very particular way to write the answer, but the actual synthetic division is just done the same. So our p of x was -x cubed minus 2x plus 5. Our divisor was x plus 1. The q of x that we got was -x squared plus x minus 3. And then our r of x was just 8. So that is the result there in terms of how they wanted us to write it. And that's it for the synthetic division problem. Okay, so for number 7, we're describing the end behavior of each polynomial, which just amounts to analyzing. So if you go back to the polynomial function section and review that, you know there's 4 possible cases on what the end behavior looks like, and all of it is determined by looking at the leading coefficient. So the term that has the largest power of x. So in this first one, y equals x cubed minus 4x squared plus 7x minus 18, that's all I care about is x cubed, the exponent and the number in front. So the number in front is 1, which is positive, and the exponent is 3, which is odd. So when you have positive and odd, that means that the left side falls and the right side rises. Think about the graph y equals x cubed. What does that picture look like? A lot of times they'll ask you to write this in the arrow notation with the infinities. So if you think about a sample graph like that, like a y equals x cubed, which looks something like this, basically as you go to the left, the negative infinity direction for x, y is going down, which is the negative infinity direction. So another way to say this is as x goes to negative infinity, then y also goes to negative infinity. So that's the left side falls. And what about right rises? That means as x goes to positive infinity, then y also goes to positive infinity. Okay. Okay, what about b? For b, we're looking at this minus 7x to the 4th term. So minus 7 is negative, and 4 is even. So in this case, we are in negative and even. And what is that behavior? Well, that's both sides fall. You know, the end behavior would look similar to like a basic graph, y equals minus x squared, you know, so a picture might look, you know, something like this. You know, both sides are going to fall. So that means as x goes to negative infinity, y is going to negative infinity, and also toward positive infinity, y goes toward negative infinity. So that's another way to say that. As x goes to minus infinity, then y goes to minus infinity, and as x goes to positive infinity to the right, y is still falling, so y is going to negative infinity as well. So that's it for end behavior. Just analyze the leading coefficient and make sure you understand the behavior. So you may want to review polynomial functions and write down the summary for the 4 possibilities there based on the leading coefficient. Okay, so for number 8 here we have an exponential model. A breed of mouse was introduced with an initial population of 360 mice. It is estimated that the population doubles each year. So A, write a model for the number of mice n of t after t years. So this is actually pretty easy because we know in general a exponential formula looks like y equals a times b to the t, where a is the initial amount and b is the growth factor per unit time step. So that's all the information you really need right there. The initial population is 360, and if it's doubling, the growth factor is 2. So that tells us that n of t should just be 360 times 2 to the t power. And that's it. So if we want to estimate after 6 years, then we just go ahead and plug that in. So this is just going to be n of 6, which is going to be 360 times 2 to the 6th. And let's go ahead and see what that is. So it comes out to 23,040 mice. So things get big quite quickly with these exponential functions, and a lot of times these types of this behavior might look like that in the short term until things like resources are curbed. This setting might be on a small island or something like that, and then eventually, once there's resource limitations, this exponential growth might stop. Anyhow, let's go ahead and move on to the next one. Okay, so for number 9, we just want to convert between logarithmic and exponential forms. So we have one going each way. The thing to remember here is just the definition of the logarithm. So that says basically if you have the log base b of some quantity x and this equals y, that can be converted, that's the logarithmic form, that can be converted to x is equal to b to the y. Or you could write it backwards, I suppose. I would normally write b to the y equals x. It doesn't matter. The equal symbol is reflexive. So we have b to the y is equal to x. Okay, so what does that look like here? Well, for part A, we just can match up. So we're starting on the left-hand side. B is equal to 5, x is equal to 625, and y is equal to 4. So that means that's all we have to do is say 5 to the 4th power is equal to 625. And you can check, and that is a true statement. And then on B, basically we're starting on the right-hand side of the double arrow statement. So we have 5 squared equals 25. So that's telling me B is 5, y is 2, and x is 25. So I could write that as the log base 5 of 25 is equal to 2. And that's all we have to do. We're just converting back and forth using the definition of the logarithm. So that's kind of what we're using up here. So this is the definition of the logarithm. All right. Okay, so for our last problem, we're trying to expand this log base 3 of ab to the 7th using the laws of logarithms. So let's go ahead and just recap those before we do this. There are 3 log laws. So A, if you have, let's say, the log base b of ab, this can be written as the log base b of a plus the log base b of capital B. If you have subtraction, which doesn't come up in this problem, log base b of, say, a over b. Same deal except for it's subtraction now, so log base b of a minus the log base b of b. And for 3, if you have the log base b of, say, a to some power p, you can bring that power down in front. So this is p times the log base b of capital A. So the first thing we can do here is we can write this as the log base 3 of A plus the log base 3 of b to the 7th, splitting that up. And then 7 is a power, so that's first using law number 1. Then using law number 3, we can bring the 7 down in front. So this can be written as the log base 3 of A plus 7 times the log base 3 of capital B. And that's it. That's all you had to do to expand. So just 2 steps there. So that is it for the final exam review. If you have any questions on these, please send me an email. This is Dr. Lennon signing off.